Welcome back to a brand new episode of LLM News, where we go through all the latest and most interesting AI stories and LLM developments. First up, we have this big announcement from OpenAI. So they released GPT-4o mini, which they claim is 60% cheaper than GPT 3.5 Turbo. So I think this is really incredible. The rapid rate of how the cost of these models and token usage is reducing. So from their analysis, they say that the model is priced as 15 cents per million input tokens and 60 cents per million output tokens. That's roughly about 2,500 pages of a standard book. And for comparison, GPT 3.5 Turbo was $2 per 1 million tokens, roughly over a year. Within 1 year, this GPT-4o mini reduces the cost to 24 cents per 1 million tokens. And this is considering this blended pricing. So I've done a few tests for this. You can check out the announcement here, but I've also done a few tests, testing the model for how good it is at structuring information, long context understanding, function calling, and also its vision capabilities. So I've done a recording on that. I'll also link that in the description for more details. Next up, I have Mistral Nemo. So this is from Mistral AI, and they consider this their best small model. They also mention here that it's a state-of-the-art 12 billion model with 128K context length, built in collaboration with NVIDIA and released under the Apache 2.0 license. I think having a model of this size that's open source will really unlock opportunities and further research around LLMs. So here are some results about this Nemo release. The performance on all the common benchmarks looks quite okay for this model size, and they're comparing with the 9 billion Gemma 2 and 8 billion Llama 3 as well. But these one have context window of 8K, so I'm not sure how fair this comparison is. However, they still report that, and the results looks really good compared to those models. So this is a very strong 12 billion model. So they refer to this as a small language model, but the small language model really varies here. Some people refer to small models like 2 billion. Some people refer to it as 8 billion or 7 billion. They are referring to their small language model as 12 billion. So just keep that in mind. A lot of multilingual capabilities. One interesting note here is this efficient tokenizer. They mentioned that in particular, it is 30% more efficient at compressing source code, the different languages. It is also 2x and 3x more efficient at compressing Korean and Arabic, respectively. Compared to the Llama 3 tokenizer, they can prove to be more proficient in compressing text for approximately 85% of all languages. One common trend here is reducing the size of these models while increasing the performance and making those tokenizers more efficient. So we are entering an era, I believe, of these LLMs where they're very cheap, very affordable, accessible, and this will unlock a lot of opportunities and more experimentation and research as well. Along with that announcement of Nemo, Mistral also announced this week the Mistral and Codestral models. So these are dedicated custom models for maths and code generation. One thing that I can highlight here right away is that these are really strong models. For instance, the Mistral is really strong in math. Codestral is also very strong. It has good code generation. I actually took it for a spin, tested it on a few code generation tasks. So if you're interested in that, I will link my YouTube video. This one is using the Mamba architecture as opposed to the transformer. So it's more effective, more efficient as well with longer context. So this is something I'm looking at very closely and experimenting with. OpenAI released this paper here for this prover verifier games, which improves legibility of language model outputs. So if you have used language models today, they get quite verbose, and sometimes it's really hard to understand the text that is producing, right? It's not too legible. So how can we improve the quality of these language model outputs while also improving legibility? This is the problem that OpenAI tries to address with this particular work. So they mention here they train strong language models to produce text that is easy for weaker language models to verify, and found that this training process also made the text easier for humans to evaluate. So you get that benefit as well, right? Stronger models, legible outputs, more trustworthy outputs, and also easier for humans to evaluate. Really what they have is these two phases of training, and they have this verifier and they have this prover as well. The prover is made up of a helpful role and a sneaky role as well. To incentivize a strong model, the proofer tries to produce text that is legible to humans. We use a training scheme where we require the strong model to produce solutions that a much weaker model, the verifier, can easily verify. In particular, we use large and small models from the GPT-4 family with 3 orders of magnitude difference in pre-training compute that have undergone a small amount of supervised training on human-written math derivations, but no extensive post-training. Just to mention as well, really important here, that they're focusing on math word problem solving as the use case. You will see some examples more at the top here and why the checkability training actually helps with legibility. So this chart is really interesting. It shows this legibility tax. We start with our only supervised fine-tuning on human-written derivations achieved high legibility but poor accuracy. So high legibility, very poor accuracy. Accuracy here is on the X, legibility is on the Y. Now, if you use something like reinforcement learning and optimizing slowly for correctness, it leads to high accuracy. You can see this high accuracy is all the way here, but has low legibility, poor legibility. And when they use their checkability game method, it creates a balance of both. So retaining high legibility, right, way at the top, and moderate accuracy. So this is your legibility tax right here. Next up, we have this really interesting paper titled Weak to Strong Reasoning. So there's a lot of really cool research papers recently that try to make these LLMs do reasoning in a more efficient way. So what they share here is that demonstrate the use of weak supervision to elicit strong reasoning capabilities in LLMs without relying on human annotations or advanced models. And that is really important because you want to be able to scale this, right? These strong reasoning capabilities without having to do the human annotations or using some advanced models. And this is really important with the human annotations because I do believe that tasks that require lots of reasoning are very difficult to annotate for humans. Now, if you have something like classification task or maybe an email generation task, those are much easier to annotate, but they are really, really difficult, complex tasks that require reasoning, planning, and more complex understanding that you would want something like this that you can automate. It says here that they report that strong models can automatically refine their training data without explicitly being trained to do so. It enables expanding a model's learning scope and scaling performance on reasoning. The recipe basically is using the supervised fine-tuning on a small, high-quality dataset and preference optimization on self-identified contrastive samples. So you would use the model to actually generate those samples. In conclusion, their finding is that extensive experiments on the GSM-8K and MAT datasets demonstrate that the method significantly enhances the reasoning capabilities of Llama 270B using 3 separate weak models. This method is further validated in a forward-looking experimental setup where Llama 3.8b instruct effectively supervises Llama 370B on the highly challenging Olympic Arena dataset. So these weaker models, right, are able to supervise the bigger ones effectively. Next up, we have this survey of prompt engineering methods in LLMs. This is a space that I very closely monitor. I've seen a couple of reports and surveys and overviews of prompt engineering methods. We also have one which we maintain with the prompt engineering guide, but this particular one I think is very comprehensive. And what I like about it is that it categorizes the prompt engineering methods by the type of tests that you can use them with. So for instance, like chain of thought, random chain of thought are really good at math problem solving. And there are all sorts of different reasoning tasks here, and you would address this with specific type of prompt engineering methods. And there are hundreds, if not thousands, of these methods. This paper went viral when I posted it because a lot of people are experimenting, building with language models, and they usually rely on some prompt engineering methods to improve performance and reliability of their applications. Next up, we have this paper called Needle Bench. Can LLMs do retrieval and reasoning in 1 million context window? We do have all these different companies or LLM providers that are focusing on these long context LLMs that can support longer context window. I think we can support up to 2 million, but there are some approaches and papers that have shown that you can extend up to 10 million and beyond. So this work basically is focusing on evaluating such type of systems. And they mention here that they're proposing a framework called Needle Bench of progressively challenging tasks to assess the long context retrieval and reasoning capabilities of large language models. They also present an ancestral trace challenge that increases the need for complex logical reasoning, which is common in real-world long context tasks. So this is sort of the performance trend that you would see here. So as the context length extends, all the performance sort of goes down, right? With most of the models, these Cloud 3 Opus models, GPT-4 Turbo, and this GLM-4 model as well. Their findings suggest that current LLMs struggle to handle reasoning tasks with complex logical relationships, even with text shorter than 2K tokens. This is what they demonstrate with this particular challenge. The big question, at least for me, has always been whether LLMs can retrieve and integrate multiple pieces of dispersed information. And I think if you can build benchmarks and evaluate LLMs this way, it will give you more or less an indicator whether it's possible to use LLMs that way, which are the stronger models that can perform tasks where you have pieces of information, in different places. So this is very common in the real world, right? You might have like PDF documents lying around and they have some relationship and you want to kind of preserve that, but you also want to understand when you put those documents together. And that is quite challenging to do with LLMs today. I think that this might be like the next step beyond the needle in a haystack, which has become a really popular benchmark for assessing the retrieval capabilities of these long context LLMs. Next up, we have this paper, Context Embeddings for Efficient Answer Generation in RAG. As you build these RAG systems, something that you will need to optimize for is the answer generation part. How do you make that more efficient? What you're proposing here is an effective context compression method to reduce long context and speed up generation time in RAG systems. As you know, when you're retrieving documents, you are optimizing the retriever to retrieve relevant documents, but that's just half of the work. You still need to worry on the generation side of things that it's efficient. And so let's say you would have documents that are very long. How do you actually optimize something like that? And they mention here the long contexts are compressed into a small number of context embeddings, which allow different compression rates that trade off decoding time for generation quality. They mentioned they reduce inference time by up to 5.69x and GFlops by up to 22x while maintaining very high performance. Next up, we have this paper that's coming from Microsoft, Spreadsheet LLM, encoding spreadsheets for LLMs. If you take an LLM and you feed it some kind of complex format like a spreadsheet or any type of complex data, I think these LLMs, they do struggle with that. And that's because they haven't really been trained in that specific domain or that type of data that has a special formatting or may have things like, in this case, all these relationship between the cells and the sheets and all these particular functions also that powers the spreadsheet. So how do you encode that in an effective way and also in an efficient way as well? They're proposing this sheet compressor that encodes and compresses these spreadsheets. And so we can enable these LLMs to operate more efficiently and effectively on top of spreadsheets. And so this unlocks understanding of spreadsheets. It unlocks different applications like analysis and so on. And something that they also mentioned in this paper is that they're doing this in a very efficient way. So they mention here, for instance, it significantly improves the performance in spreadsheet table detection tasks, outperforming the vanilla approach by 25.6% in GPT's in-context learning setting. Moreover, fine-tuned LLMs with sheet compressor encoding has an average compression ratio of 25x, but achieves a state-of-the-art 78.9 F1 score, surpassing the best existing models by 12.3 on those type of tasks. In addition, they also mentioned this chain of spreadsheet, which can unlock even more powerful applications in this particular domain. So for downstream tasks such as spreadsheet understanding and validate in a new and demanding spreadsheet question answering task. So you can ask questions and you can do this high level analysis of this spreadsheet. So next up, we have this exciting announcement from Andrej Karpathy. So he has left OpenAI for a couple of months now, and everyone was kind of waiting for what he was going to do. And he has been really focusing on education the past few years. He has announced that he's starting an AI plus education company called Eureka Labs. And here are more details about the announcement. He has plans to develop a course called LLM 101, and this is an undergraduate level class that guides the student through training their own AI system, very similar to the smaller version of the AI teaching assistant itself. So he has a lot of ideas of this. I'm also very curious from edtech perspective, what are the type of maybe models or even type of resources that he is going to work on and his team. And so I'm excited about that. And lastly, I wanted to highlight this Llama Factory, which provides a web UI for efficiently fine-tuning up to 100 LLMs. So there are a bunch of LLMs, and some of the features include support for various models. They integrate methods like PPO, SFT, make that easily to use. Also like scaling type of methods as well. Advanced algorithms like Dora, Long LoRa for practical tips as well, like flash attention to make inference much faster, experiment management tools such as TensorBoard, 1DB, and so all that integration is there. And also like faster inference like OpenAI style APIs and greater UI. So it's all-in-one type of tool that allows you to efficiently fine-tune models, test them, and also track experiments and so on. And that's nice because sometimes you just want to test an idea, right? You may have a data set already, maybe test some of these newer methods. So it's cool to have a tool that integrates all these methods and gives you that in an accessible way to train models or any of the smaller models, even bigger models that you may be interested in to unlock some type of application. That will be it for this episode of LLM News. Thanks again for supporting the channel. Please consider leaving a like and subscribe if you haven't, and stay tuned for the next one. Bye-bye.